Clearly, buildings are composed of various structural elements such as slabs, beams, columns, and footings. Each of these structural members plays a certain role in a structure. This video is going to present you various aspects of these structural members, for instance, their function, types, or loads imposed on them, and load transfer mechanism for one of those to another, so you know what is a slab, a beam, a column, and a footing in construction. Greetings and salutations, builders of the world. My name is Jesus Arroyo, an architect building here in Mexico, and we're going to talk about slab, beams, columns, and this is Planos Constructivo, so we talk about pretty much about construction. A slab is an important structural element which is constructed to create flat and useful surfaces such as floors, roofs, and ceilings. And it is a horizontal structural component with top and bottom surfaces parallel or near so. Commonly, slabs are supported by beams, columns, concrete or steel, it depends, walls, or the ground. The depth of concrete slab floor is very small compared to its span, so you gotta watch for that. So what are the types of loads on a slab? The types of loads acting on a slab include dead load of the slab, we've talked about in another video, the live load, the floor finishing of the also the snow loads in case they have snow and weather conditions like that, earthquake loads, the transfer, the load transfer mechanism in the slabs are also very important to analyze, which we will do in this video. And the forces the transfer from the slab to beams occur either in one way or in two ways. The total system complete counts on the geometrical dimensions of the slabs. Slabs might be supported by columns only in this case, or two-way action will prevail. If the ratio long side short side is 2 less than 2, it is considered as a two-way slab, and if longer side to shorter side greater than 2, then it is considered as one-way slab. The load transfer mechanism from floor slab to supporting elements for one-way slab and two-way slab are shown right now. So there is one-way slab, and if you see, this could be as long as 2 meters or 4 meters. Let's just say it's 4 meters, and this is 50 meters or something. If it's not like the span of this is not like that long, it could work as a one-way slab, and pretty much all the forces working acting on the slab, pretty much the load goes to either this side or this other side, and that's pretty much how the weight is spread. So pretty much all the walls or structural elements such as slabs and the beams would be carrying all the load on the sides. But if it's like a two-way slab, well, it's distributed like this in a triangular way, or also like this, and it's gonna be spread on all the beams or walls. It depends on what it's working in. You see beam B, beam A, and it's important to notice that it goes more like this. That's what I always ask the people who's asking me and telling me I have a slab and it is 25 square meters. That given a square meters, the number of square meters is not as important, and how much is your slab is 4 meters by 13 meters or something like that. It's more important than the number of square meters you have on it. So we can pretty much watch on the spans. The longest span and also the shortest span are the most important things to watch out for the calculation of the slab and the structure. Also, it depends on how the structural elements are arranged. If you have walls like in this example, you have walls, and on all of those sides it would be spread like this. But if you only have columns, then you have all the load, and all the loads of the slab will be pretty much spread like this. It depends on the column, you know, it goes, this area goes to this column over here, and this area goes to this column over here, and so on and so forth. But if you have, you know, like slabs, you don't have walls, but you have beams and on your slab, then it will be spread like in the same way of if you have any walls or something like that. Now, beams. The beam is a horizontal and structural element that withstand vertical loads, shear forces, and bending moments. The loads applied to a beam result in reaction forces at the support points of the beam. The total effect of all the forces acting on the beam is produced shear forces and bending moments within the beam that in turn induce internal stresses, strains, and deflection of the beam. And when it comes to the types of loads of the beam, you know, it's pretty much the self-weight of the beam, the dead load that includes point load, for instance, column constructed on beams, distributed load, for example, setting slabs on the beam, the live load, the torsional load. The load transfer mechanism in beams, well, they transfer pretty much the loads imposed along their length to their endpoints, where the loads are transferred to either columns or walls or any other supporting structural elements. So you heard it, folks. Pretty much this is the beam. I'm gonna draw it in green. Let me draw it again. What did I do? Okay, so here we go. This is the beam on green, and it pretty much transfers the weight on the ends of the beam, the end points, to the columns or walls. If it's a wall, then pretty much it'll work all along the way, but you have to make a difference between the what we call in Mexico castillo, which is a tie column, or also, you know, there are bonding beams, which are different. Bonding beams and tie columns are pretty much working on walls, while the regular beam and irregular columns, they work as single element. It's pretty much very important. And speaking of tie columns or columns, let's talk about a column is a vertical structural member that can carry loads mainly in compression. It is assumed to be the most crucial structural element member of a building because the safety of a building rests on the column's strength. This is because failure of a column would cause progressive collapse in building, whereas such event would not occur when other members fail. What this means is if another member fails, it's not going to happen like if you pretty much demolish a column and it's gonna pretty much fall like a domino. Pretty much like a domino falls, the entire structure is gonna go down. So columns transfer vertical loads from a ceiling, floor, or slab, or from a beam to a floor foundation. They also carry bending moments about one or both of the cross section or section axes. Self-weight of the column multiplies by the number of floors, and also, you know, pretty much the types of loads is like the self-weight, as I just said before, the loads of walls per running meter, the total load of the slab, that includes the dead load or live load, the self-weight. Also, you know, the load transfer mechanism. Since the columns are supported by foundation, the load relocated from to all components to the columns. Then it will be transferred from the column through the column next adjacent to the footing in the form of axial force. Moreover, columns transfer lateral loads to foundation as well as such loads imposed. Lastly, it will transfer the moment and shear also to the footings. Now, footings. Footings are structural elements that transmit load of the entire superstructure to the underlying soil below the structure. Footings are designed to transmit these loads to the soil without exceeding its safe bearing capacity, thus preventing excessive settlement of the structure to be tolerable limit to minimize the differential settlement and to prevent sliding or overturning. What pretty much the types of loads of the footing are, you know, the entire structure, the dead load, the self-weight of the elements, the superimposed loads such as finishes, partitions, block work surfaces, live loads, impact load, snow loads, wind loads, earthquake forces, soil pressure, rain loads, fluid loads. And pretty much the mechanism for the transferring is the soil is the root support of the footing. All the forces that come in contact with the footings will be transferred to the soil. So the soil shall bear these loads by the aspect known as bearing capacity. The bearing capacity changes from one type of soil to another, and this is key factor in estimating the size of footings. There's also, you have to check on the mechanical strength of the soil before pretty much doing all the calculations of the structure. So there are tests and laboratories who pretty much they dedicate to that before any construction. So before entering the construction site, you gotta do the mechanical tests, so to check on the bearing capacity of the soil. So now let's review again this image to check on how the loads are transferred from element to element on the structural side. So you have the slab, the main slab, and this is the whole area, and as we saw before, it's gonna pretty much spread all the load like this, and the red area is gonna transfer to the red beam, which at the same time is gonna pretty much spread onto the let's say the green or the purple side goes to the purple column, and then the blue column, the blue side goes to the blue column, and so on and so forth. It goes like that. So then it goes to the footings, and also you see these arrows that are pointing upwards, but pretty much it's not that the strength of the soil is going upwards, but it's like pretty much how it compensates. It is as if the soil would be the strength of the soil is pushing upwards, but it's not in reality like that. It's actually the whole structure of the building that it's going down, and pretty much the soil have to bear with it. This is how it works. And also, you gotta check out, because this last image is very important, because you have the column or the neck of the footing, and also you have like the width of the footing, and also the main element for the calculation of the footings, the design of the structural elements on the footings is the capacity of the soil. And another one very important is the footing width, because there's a critical zone for compaction, so you have to compact all the soil underneath the structure, and it'll be pushing downwards. But also the footing width, it'll go like this. Soil pressure will be cut at 1/2 at this level, at this pretty much at the same depth, pretty much the same level of the footing width. But if you go 2 times the footing width, the soil pressure will be cut by 2/3 at this level, and it'll go so on and so forth. So pretty much it'll fade. There will be one depth that it'll fade out, and so you pretty much do tunnels and stuff like that. So pretty much this is it. I hope this had worked for you. And if you want more videos like this, don't forget to subscribe and give us a like. Also, if you have any questions or comments, don't forget to do it below. Pretty much working in Mexico, I know that this is very weird step that I'm doing, because I know that there are different methods and ways of constructing in all over the world, but I want to check out what's going on out there and improve my audience. I usually used to do these videos in Spanish, but I want to spread this word to the world and see what people is up to and what they contribute to my channel, and also what I can contribute to you. So thank you very much. This is it, and see you again.